Okay, in this video here we're going to be looking at substitution, evaluating and equivalence. Okay, so equivalent expressions. So the learning goal is there for you to copy down, and hopefully you understand what these terms are by the end, and also that you can evaluate expressions using substitution, and also that you know how to determine if expressions are equivalent. So we'll focus on the first two here, and we'll get you write down a couple of definitions. And the first one is substitution. We use this all the time with algebra, and substitute basically means that as we have pronumerals, you're basically just replacing the pronumeral, and I'll highlight that. You're basically just replacing the pronumeral with an actual value or a number. And you do that to help you determine the answer. So once you've, as it says there, once you've substituted, you replace the pronumeral in expression, and then you use that number to find an answer. And effectively finding the answer is what we call evaluating. So when it says evaluate, it means that you substitute and find the final value. So if we had a quick look at what that might look like, we've got, if we got told that y equals 3, okay, so we're going to substitute y, and we've got this expression. You have 4 plus 2y, and we're now told that y equals 3. So what you're going to do is you're going to substitute this 3 into the pronumeral, which is the y, okay, and it says there, so you replace the actual number of 3 with the pronumeral of y, and now you can actually do what we say here is evaluate. So now that you've substituted in, you can actually evaluate that expression. So 4 plus 2y is like 4 plus 2 times 3 because we've substituted that 3 into the y. We'll do 2 times 3 first, knowing order of operations, which makes 6. And then we have 4 plus 6 equals 10. So what we've done here is we have substituted in for the y, and then we have evaluated by getting our answer. So if we looked at a couple of examples of how to actually do that, we're going to use these following examples. So we've got substituting. We're going to put 3 in for x, and we're going to put y 6 in for y. So we're going to substitute that in, and then we're going to evaluate. So we have 5x, and we know that that means 5 times x. So basically, if we have substituted there and there, we have 5 times 3. Which we know equals 15. So we've just evaluated after substituting. Now we might get a bit more complex ones, as we can see in this example here. So we have 5x squared plus 2y plus y, and we can just now substitute in for our first part. So we have 5 times x squared, and x will be 3 squared, plus 2y is 6, plus x, which equals 3, okay, and we can just go through our order of operations and answer this. So we'll start with our order here with 3 squared equals 9. So 5 times 9 plus 2 times 6 plus 3. I want to break this one down first. I have my two multiplications here. So I have 45 plus 12 plus 3, and then I can work through that there. Is 60. Okay, so we can just simply, as I said, you substitute in the value into the pronumeral, and then you evaluate to get your answer. Now, another key thing that we do with algebra is when we determine equivalent equations. Now, when we've looked at fractions, for example, if I did an example of 2 over 3, to create equivalent fraction, I multiply a number by the top, then I have to do it the same to the bottom, okay, which would give us an equivalent fraction of 4 over 6, and we kind of do the same thing when we're looking at equivalent equations, but in this time we use the RHS and the LHS. So if we have an expression here like this one, let's just say here we've got 5x equals 15, let's just say that we have the right hand side, okay, and we also have the left hand side, and we want them to, when they're equal, and we're going to adjust them because that's how we can help create an equivalent expression. But we'll write down a few definitions first before we get into that. And the key thing here is that two expressions are equivalent if they have equal values regardless of the number that is substituted for the pronumeral. Okay, so if RHS equals LHS. So an example would be here. We have 5x plus 2 equals 32 is equivalent to 5x equals 30 because both equations have the same solution where x equals 3. Okay, so in this case, x equals 6, x equals 6 and x also equals 6. So they are equivalent equations because they have the same value for the pronumeral. So equivalent equations can be represent an infinite number of ways that have the same solution, as we've just sort of looked at above using the LHS and the RHS, and that can be created by performing the same operation on both sides. So as we said, if we've got fractions, we perform the same operation to the top numerator and the bottom. In expressions, we perform the same operation to the LHS and the RHS, and that's how we create equivalent expression. But what we're going to be looking at today is how we can determine if they are, and we're going to use those things of substituting and evaluating. So here the question is x minus 3 and 3 minus x, are they equivalent expressions? So the way you want to do this is you want to substitute a value in for the pronumeral. So let's just start with, let's just say 3. Let's just say if we substitute x into 3. So I have 3, this case would be 3 minus 3, and this one would be 3 minus 3. Okay, and they're both going to give us the answer of 0, so that is correct. However, if I choose another value, let's just say I want to make it 2. Let's just say x equals 2. In this expression, 2 minus 3 equals negative 1. But for this expression, 3 minus 2 equals positive 1. So they're not actually equivalent because we get different values or different answers depending on what you substitute in for x. Now, if I did the same here for a and b, and I'll do, okay, we've got two sort of examples here. Let's just say a equals 3 and b equals 4. We want to substitute in to see if these are the same. So here, for a is there, so we'll have 3 plus 4 equals 7, okay? And for this one, b is 4 plus 2 times 3 minus 3, okay? So I'll have 4 plus 6 minus 3, which equals 10 minus 3 equals 7, okay? So they are equivalent expressions, and now I want to try the other options as well. So again, you want to try and put in another one. So let's just change these here to 2 and 1. Okay, and if I pause that here, I'll do the working out for you. Okay, so I've just done the working out for both of these, and you'll see that the answer is 3 for both. And even on this side, we did the working out, and the answer was the same for both. So these two expressions are equivalent. So you determine that by substituting in for the pronumeral and determining if you get the same value or the same response for the LHS and the RHS. Thanks, guys.